Hello everyone, in this video we'll present the Serverless Workflow Project. Serverless Workflow is a cloud-native computing foundation sandbox project. It is part of its serverless working group. It is open source and under the Apache 2.0 license. The project is fully community-driven. Here you can find some information about GitHub repository, website, and the community chat and meeting information. Serverless Workflow defines a declarative and domain-specific workflow language. Declarative, it is not expressed in low-level code, however, defines an abstraction language which you can express in both JSON or YAML format. Domain-specific, as it targets the domain of orchestration of event-driven distributed services. As an example, on the left-hand side, we have two simple requirements written in natural language. When a patient has a bladder infection, for example, we want to notify a urologist. And similarly, if a patient has irregular heartbeat, we want to notify a cardiologist. On the right-hand side, we see the serverless workflow does not express these types of requirements as if-else statements or using code. Neither does it express it using terminology that does not fit its domain. On the bottom, we'll see that in this particular case, with serverless workflow, we can translate these requirements written in natural language directly into events such as bladder infection or a patient having irregular heartbeat, events that could be generated by different hospital systems, for example, and services. So, for example, notifying urologist or notifying cardiologist in this case would translate into invocation of distributed services. Serverless workflow is based on standards. We use the cloud event specification to define events that are produced, consumed during workflow execution, and also the correlations of the many different events you might have in your systems. We use the Open API specification to define which services and their operations need to be invoked during workflow execution. The serverless workflow specification then defines control flow patterns, including execution order, error handling, data management, and such, which are all based on widely used and known workflow patterns. In order to start utilizing events during our workflow execution, we have to define them. Events can either be consumed or produced by our workflows. And here you can see that with serverless workflow, we have a direct one-to-one mapping between how these events are expressed with the cloud events format and also how they're defined within your workflow using the serverless workflow language. When correlating events, again, we utilize the cloud events format and particularly their context attributes. So now that we have defined our events, let's see how we can interact with them. There are different things that events can do during our workflow execution. They can either start workflows, they can continue execution of existing workflows. They can, like we said, be either produced or consumed during workflow execution. And they can also be used to make logical decisions. On the right-hand side, we see a simple example of the serverless workflow format where we have a definition that says when the workflow ends, we want to produce an event of type workflow completed event. This then event that is produced by our workflow can be consumed by other workflows or other services within our systems. Similarly with functions or services that we want to invoke during execution of the workflows. Serverless workflow utilizes the Open API specification here. On the left-hand side, you can see a simple Open API definition of a service, and particularly one of its possibly many operations that it provides. On the right-hand side, we can see how we can define the service and its operation within the serverless workflow language. We have here the operation parameter, which is basically a combination to a path or a URI to the Open API definition, and also the unique operation ID defined in this definition. So with just a simple statement, you can specify exactly what kind of operation on a service you would like to be invoked during workflow execution. Now we understand that there are many different ways of invoking services. With serverless workflow language, you can invoke both RESTful type of services, again, utilizing the Open API specification, but you can also invoke services that might not be exposed or be able to define as with a RESTful type of declaration, however, are triggered by events. The final part of defining a workflow is the states and the order in which they're executed. States in serverless workflow define the control flow logic blocks. A state can get data input or the information from an event, can process this data given what control flow logic piece it executes, and then can produce a data output or produce an event which then can be consumed by other parts of the workflow or other services that listen for it. Serverless workflow defines explicit control flow, which means that you can clearly define what you're building. It has many different control flow logic pieces. For example, you can define a sequence of execution. You can define looping structures, parallel or sequential execution. You can do decisions based on data information or event payloads. You can issue retries when there's some possible issue. You can clearly define error handling within your workflows. And you can do other things, for example, define a human decision which has to be performed during workflow execution. Now let's take a look at all the different project components of serverless workflow. So far we've been talking about the serverless workflow language. This language is defined via JSON schema, which declares all the different rules of the serverless workflow language. In addition to the language itself, serverless workflow also provides a number of language extensions. Those do not influence the actual execution of the workflow, however, enhance it with additional information. Some examples of that are KPI or key performance indicators, information for tracing, and also simulation. During runtime execution of the workflows, different services can utilize this extra information to give us more information about the execution of our workflow, which can be used for things like improving the workflow performances, costs, etc. In addition to the extension, serverless workflow also provides things like software development kits, TCK as in compatibility kit for runtime implementations to test their implementation against the serverless workflow specification, and also in addition a number of plugins such as plugins for IDEs and things like that. So let's quickly take a look at one of the extensions provided by serverless workflow, which is the KPI extension. The key performance indicator extension allows you to compare expected results of your workflow execution with the actual results which can be gathered during the runtime. The KPI extension allows you to improve workflow performances, costs, and effectiveness. The next thing we want to look at is the serverless workflow Java SDK. The Java SDK features parsing of both JSON or YAML definitions of the serverless workflow language. It provides a fluent API so you can build your workflow models using plain Java. It provides workflow validation. It also provides generation of a diagram where you can visualize your JSON or YAML workflow definitions. Another thing we wanted to look at is the Serverless Workflow VSCode plugin. This is a plugin that's publicly available on the VSCode marketplace that you can download now. And its features are, it provides code hints and code snippets for the serverless workflow language for both JSON and YAML files. It also provides validation against the serverless workflow language schema. And in addition to that, it also provides diagram generation. So as you are developing your workflow models, you can preview the generated diagram to see it visually. So that's it for the introduction. For more information, please visit our website at serverlessworkflow.io. Thanks.